Dear students, today we are going to study about the vapor pressure of a liquid mixture. Our lecture M1. The topic vapor pressure of liquid mixture. For this, we are selecting a binary solution. That is a mixture made up of two components. Both the liquids are volatile. Let P1 equal to vapor pressure of liquid 1 at a certain temperature. Let x1 equal to mole fraction of liquid 1 in the mixture. Let P2 equal to vapor pressure of liquid 2 at the same temperature. It's a mixture. I have given here a simple figure. Of course, both at the same temperature. X2 mole fraction of liquid 2 in the mixture. Now, according to Raoult's law, P1 proportional to x1. The vapor pressure of component 1 proportional to its mole fraction in the mixture. Therefore, P1 equal to P10 into x1. That is also according to Raoult's law, where P10 is the vapor pressure of pure liquid 1 when it is in pure form, of course at the same temperature. Similarly, we are able to write P2 equal to P20 into x2. The vapor pressure of pure second liquid and its mole fraction in the solution. Now, according to Dalton's law of partial pressures, P total equal to P1 plus P2. Here I have tried to show that this is a liquid mixture and its vapors I have shown like this. This one is the liquid mixture, liquid 1 and liquid 2, and their mole fractions are x1 and x2 respectively. Now, vapors are formed. The total vapors will exert the pressure will be the P total. The total vapor pressure on the surface of liquid mixture. Now further, therefore, further, P total equal to P1, that is P10 into x1 plus P2 is P20 into x2. Further, P10. Now, you must be knowing that total mole fraction of a solution is always 1. So, x1 plus x2 is 1 here. And therefore, we can write for x1, 1 minus x20 plus P20 into x2 equal to, remove the bracket, P10 minus P10 into x2 plus P20 into x2 equal to P10. Now out of these two, we will take out x2 common. I will write this term first, then this. So this term plus P20 minus P10 into x2. Conclusion from this study is, that is, P total is linearly proportional to x2, that is mole fraction of second liquid component. Further, again according to Dalton's law, P1 is also equal to P total into Y1 and P2 equal to P total into Y2. What are Y1 and Y2? Y1, the mole fraction of liquid 1 in vapor mixture. Y2, the mole fraction of liquid component 2 in the vapor mixture. So, x1 and x2 are the mole fractions in the liquid form, liquid mixture. Y1 and Y2 are the mole fractions in the vapor phase. This is also according to Dalton's law. Now, conclusion. We have very useful relationship from this is, earlier we had written P1 equal to P10 into x1, and now P1 also equal to P total into y1. These relations combinedly are quite useful in solving the numericals, the problems. What is left out is about study of this graph. It makes the ideas more clear. Let us see. Here, the liquid mixture which we have selected has got, let P10 less than P20. That is, vapor pressure of pure liquid 1 is less than that of pure liquid 2 at the same temperature, of course. It is shown in the graph. Look here. Mole fraction of liquid component 1 is 1 at this point. Means it is only pure solvent 1 if taken separately. Then P10, its vapor pressure. All measurements done at the same temperature. See that at this point, it is pure component liquid 2, mole fraction is 1. Means it is the pure liquid. Number 2, its vapor pressure P20 and P20 greater than P10. Now, while going left to right, the mole fraction of component 1 goes on decreasing. Say at a certain point, mole fraction of component 1 is 0.4. From 1 it is 0.8, 0.6, 0.4, 0.2, 0. Now here, at this point, mole fraction of second liquid component is 0 because it is absent. Now, its mole fraction goes on increasing left to right. Here it becomes, at this point, 0.6, and at this point it is 1. Okay. Now, what does this line indicate? What do the points on this line indicate? On this line, every point represents value P1 calculated by this relationship. Value P1 corresponding points. It is shown here. Now, what do these points on this line indicate? They all indicate P2 values because mole fraction of second component goes on increasing. Then the vapor pressure P2 also goes on increasing. And when mole fraction of second component 1, the vapor pressure of second component also maximum, P20. Now, on this line, each point indicates P total. To understand that, let us take reference of this point. That how does it give P total equal to P1 plus P2? Select a point, draw vertical line. I have shown by red line. Now, at this point, here, this value, here to here, this value indicates P1. Because all the points on this line indicate value P1. Now, on this graph, the corresponding point here, then this value indicates P2. So P1 and this much P2. Now further, when we draw the graph, we find that this value, this length and this length are the same. So when this much value is P1, then this much value is also P1. Now finally, look here, starting from this point up to this point to this point, this value here to here is P2 and here to here it is P1. So at this point, the total value is P1 plus P2 and P1 plus P2 is P total. So, a study about vapor pressure of liquid mixture, we will go further in the next lecture. Thank you.